So we're going to talk about how the net force affects the motion of an object in this lesson. The learning target is to be able to describe the motion of an object using balanced and unbalanced forces. So let's look at some situations here. A biker is moving at a constant speed of 5 meters per second. Are the forces acting on her balanced or unbalanced? The key word here is that this is a constant speed describing this biker. And so remember, if we're reviewing from before, last lesson that we had, whenever we see balanced, we know that that object is either at rest or it is at a constant speed where it is not accelerating at all. It's not speeding up. And whenever we have an unbalanced force, that object is accelerating. And so that object's speed is changing. And so in this case, since this biker is moving at a constant speed, the forces acting on this biker would be balanced. If they were starting to pedal, right, and transmit more force to the bike, and the forces became unbalanced, now they would start to accelerate. But since they're at a constant speed, these forces are balanced. So if you look at this one, a biker's moving at the speed of 5 meters per second and then hits the brakes until she slows down to a stop, so where the forces acting on her balanced or unbalanced. Well, this would be slows down to a stop. And we know that if we slow down, we are accelerating. And so since we have an acceleration, the forces would be unbalanced in this situation with this biker where they're changing speed. So that's how we can tell whether the forces are balanced or unbalanced based on an object's motion. And so if we look at some force diagrams now, the skateboarder is moving at 2 meters per second to the right when the following forces act on him. What is the net force acting on the skateboarder and what will happen to his motion? So the reason why we ask this question is because the first thing we need to know before we look at how the object's motion has changed is we need to know whether the forces were balanced or unbalanced. And remember, if the forces are balanced, then we're going to have a net force of 0. If I have two forces acting on this object and they are equal and opposite from each other, so they are balanced, my net force equals 0. And so if I say that these forces are balanced, then we know that nothing's going to happen. They're going to keep moving at the same speed. So we've first got to decide if they're balanced or unbalanced. And from that, we can figure out the net force. If there's a net force, then they are unbalanced. And so we look at this object here. We have 50 newtons going up, 50 newtons going down. Remember, those cancel in the up-down direction. And we have one single force moving to the left, or acting to the left, I should say. So my net force, F net, is going to equal 20 newtons. And so there's an unbalanced force acting on this object. And so this object is going to accelerate to the left. Now, what that means is different based on what the object is doing. So I know that it's going to accelerate left. Okay, but in this situation, it's moving to the right. And so if this object is if it's moving to the right, but it's accelerating to the left, this object is going to slow down. Its speed is going to decrease. And so it'll eventually slow down until it comes to a stop. And then if this force keeps acting on it, if we still had a net force of 20, even though this is from friction, it would start to speed up back in the leftward direction. But because it is moving to the right and accelerating left, it is going to slow down. So we look at this situation. If we have the following forces applied to an object, we have to decide, are they balanced? I look at my object here and I see an up, down, equal, and opposite. I see a left and I see a right that are opposite but not equal. And so this is going to not be a balanced force. My rightward force is bigger than my leftward force. And if I look at what direction is the net force in, because I've got to know the net force in order to decide what the motion of the object is going to be. And I see that my rightward force is bigger, so I have F net is going to be the right. I don't know how big it is. I know that it's the difference between my rightward and my leftward, but I don't have a number for it, so I'm just going to label it. And then how would it affect the motion of an object? Well, if we have a force acting to the right on this object, I know that it is going to accelerate to the right. Okay, it is going to have an acceleration to the right. Now that can mean different things based off of what the object is doing. If it is at rest, it is going to speed up, and it's going to do that in the rightward direction. Now, if it's starting off where it is moving left to start off with, let's say the skateboard was moving to the left, and all of a sudden I put a force on it to the right, it is going to slow down. Okay, but it's still going to be moving left. It is still going to be moving left, but it's going to slow down until it stops, and then it's going to turn around. If it is already moving right. So now it is moving in the direction that it is accelerating in. It is going to speed up, and it's going to do that in that rightward direction. And so we can see how these different starting motions of this object are going to affect what it's doing when that force is applied onto it. They are all going to accelerate to the right, but that means different things based off of whether it's already moving, if it's moving right, or if it's moving left. And so that's really what we've got to get down here with this net force and figuring out how that affects the motion of the object. But that would be the answer for this one. And so if we looked at this object, if an object was falling through the air and these forces were being applied onto it, we first decide, are they balanced? Right, well, I look at my force of gravity going down, I look at my upward force, could be force of air resistance here. I see that my force of gravity is smaller than my upward force, and so these forces are not balanced. I look at what direction is the net force in. Well, my upward force is bigger than my downward force, and so I would know that my net force is going to be upwards. I don't know how big it is. I know it's the difference, but I know that it's going to be upwards. And then how would this affect the motion of the object? So this object is already moving downwards, and so since there's a force upwards, this object is going to accelerate up. Now remember, that means different things based off of what it's doing. If it was at rest and we had a force like this where we have a net force moving upwards, it would start to move up with that acceleration. If it was already moving up and we had this net force acting upwards, it's going to speed up in the upward direction. But since this object is already falling down, and we have a net force acting upwards, this object is going to slow down, but is going to keep moving downwards. Okay, it's going to slow down, but it's going to keep moving downwards because there's a net force acting upwards, and it's already moving downwards. And so that's how these forces would affect the motion of this object. So there's a couple of questions that we've got to ask ourselves as we're trying to figure out how the net force affects the motion of an object. First, we've got to decide what is the net force. Once we decide what direction the net force is in, then we can look at what the object's motion is already doing. If it's at rest, we ask ourselves and say, yes, this object is already at rest. Well then, the object is going to speed up in direction of net force. And this makes sense, right? If I had a box and it's sitting there on the table and all of a sudden I push it in this direction, it's going to start to move in that direction that I push it in. And so if it's sitting there at rest, the net force of the net force. And then if we ask ourselves, if it's moving, right, and we say that yes, it's moving, then we've got to decide, are the net force and the motion of the object, the way that it's moving, in the same direction? Because if this object is already moving in this direction, now we're going to push on it in the same direction that it's moving. It is going to start to speed up. Right, and that makes sense. If I have this box already moving and I give it another push, it's going to start to speed up in that direction. It's going to accelerate there. If we have this object, which is moving left, but all of a sudden I go up to it and I start pushing it right, it is going to start to slow down. This is like if you had a car that was moving towards you, maybe not very fast, it was just rolling towards you, and you put out your hands and you tried to push really, really hard, and you actually tried to slow it down. You are opposing that object's motion, and so you are going to slow down that object. But I hope that this helps with figuring out how the net force affects the motion of an object, and really being able to take the motion of an object and look at what is the net force acting on this object.